In this video, the uniform fault-tolerant control of a quadcopter with rotor failure is introduced. In the past decade, the fault-tolerant control on the quadcopter has gained considerable attention due to its essential role in improving system safety. However, without the rotor redundancy, this kind of vehicle suffers most from rotor failures. Most research considers only a partial loss of the rotors. Few studies address the problem of the total failure of one and more rotors. The studies addressing the problem of the total failure of rotors need to design multiply controllers for different cases, which results in memory-consumable and complex controllers. Therefore, this study proposes a uniform fault-tolerant controller for a quadcopter without controller switching in case that one rotor fails completely. The controller covers from the flight in normal to the one that in the event of fatal failures of rotors. In detail, the control channels are divided into the horizontal channel, the thrust channel, and the yaw channel. The horizontal channel is given the highest priority to counteract the gravity, and the yaw channel is given the lowest priority. The different priorities are achieved by the quadratic programming in the control allocation. Then the experiment video, the control method, and the hardware-in-the-loop platform and simulation video will be introduced successively. Experiment video. Controller introduction. As shown in Block 1, the position loop adopts the PID method and the incremental nonlinear dynamic inversion method to obtain the desired acceleration and thrust, respectively. And the desired primary axis is obtained as Block 2. In the attitude loop, the attitude control, deduced from a Lyapunov function, gives the ds-red angular rate corresponding with Block 3. The angular rate control gives the desired torque with the incremental nonlinear dynamic inversion method corresponding with Block 4. The rotor dynamics compensator adopts the proportional controller shown in Block 5, with the actual control channel observer shown in Block 7. The control allocation, shown in Block 6, adopts the quadratic programming to obtain the desired lift force for each rotor. Hardware-in-the-loop platform and simulation video. In this study, we design a SoC FPGA-based hardware-in-the-loop simulation platform to run the fault-tolerant control simulation. The platform uses an ARM A53 1.2 GHz core to run the quadcopter model real-time at 2 kHz and uses the FPGA interconnects the ARM core and Pixhawk 4 by simulating real sensors, which includes the inertial measurement unit, the magnetometer, the barometer, and the GPS. Thank you for your watching.